Okay, it is Thursday, May 29th, and this is the fourth day. Let's see. Okay. Yes, this is the fourth day of coding every day. Trying to do some interview preparations. Yesterday we worked on two mediums. We did some two-pointer mediums. Yeah, I think I have some time today. I think today I want to see if I can maybe do three mediums. I'm thinking maybe group anagrams, top K frequent elements, and min stack. Alright, let's get to cracking. So, group anagrams leet code. Okay. So, given an array of strings, group the anagrams together. And the anagram is a word or phrase formed by rearranging. Formed by rearranging the letters of a different word or phrase using all of the original letters exactly once. Okay. Is it constraints? Like I said, I don't have to convert anything. Everything's already lowercase. Oh. So, the way I'm thinking about working this is, I'm trying to see. So, okay, my first naive thought would be to, let's write this one down. My first naive thought is going to basically get the character count, we'll say create a character count dictionary for each word, right? So that's going to basically be in dictionaries of K letters. So that's pretty big in terms of size. And then I basically I would say I would then just group the dictionaries that are the same. So I would have to do a n squared. Man, I'm so sorry. Then I would check each dictionary to each other, which is pretty big. That's a pretty big check. Honestly, at this point, I feel like the easier solution is literally just to sort. Man, feeling so yawny today. Had a long day of coding. Kind of pooped out right now. This is gonna suck whenever I get to some of the harder ones. Okay. I don't think that is the correct approach, though. So I'm gonna say another one is a sorting approach. I would sort each word by alpha bit value. And then I would I think the sorting approach might actually be my move. But that's gonna be like n times n squared. Screw it. Let's find out. So I'm gonna say for element and strings. And then I'm gonna put a dictionary out here. Say dictionary. This is not descriptive at all. Oh, I'm so tired. I'm so sorry. Apologies. Keep yawning. Gotta wake up. Gotta wake up. Okay. I would then basically say, does it have to be ordered? The order should not matter, right? In any order, thank the Lord. Okay, any order is fine. So I'm gonna say if element dot sort. Wait. Python sort string alphabetically. I hope you don't hear my dog. My father's not home, which is really upsetting him. I don't remember. I don't know if this is gonna break because I don't know if a string's allowed to be the beginning, but in Python it's not mutable, so we'll see. Okay, so basically what I'm doing here is I'm saying sort the string. If the sort of string exists inside here, then we're just gonna run it through. We're gonna append it, just solid. So that basically will check for anagrams, and then we'll do like an else. Oh my days, if I could type. So if it's not sorted, then dictionary of sorted string is going to equal a new array. Okay, and then I'm just going to make a array called solution, and then just say for key and dictionary, solution dot append dictionary key, and return solution. I don't think this is gonna work. I'm having a feeling this might break, or not. We'll see. On the submit, this is where you get. Hey, it worked. I feel like that's not right, but check it off. Let's watch the video. Let's watch Mr. Neatcode's video. I bet.
Hey everyone, welcome back, and let's write some more neat code today. So today let's look at our good 0 z end.
Oh. Oh wow, that's it? What? Hold on, okay. This is the sorting one. This is hash table. Default dictionary list. I've never heard of this before. What is default dictionary? Especially dictionary uses subclass and collections modules. Its primary feature is to assign a default value to a key that doesn't exist, avoiding key error exceptions. Instead of raising an error, default dictionary uses a default factory function, passes an argument to create a new entry. Oh, I'm so sorry. He's just creating an empty dictionary. I should be reading better. What am I even doing? He's creating an empty dictionary of lists. He's just being very specific for what it will be doing. And he's gonna say for string and strings, the sorted string is gonna equal the sorted thing, which is what I did, and that. Oh. Okay. I mean, wait. That's literally what I did. I just kind of wrote it out more. Huh. So time complexity for the hash table is much better. So this one's the one I was curious about. So he creates a dictionary, and then he does a string of strings, and then he does a count. The count is 27 characters. Ah, okay. Oh, he turns it to a tuple. Ooh, that's pretty smart. He kind of gets like a numeric value out of a tuple. I like that. That's pretty cool. Okay. Nice. Not mad at that. Top K frequent elements. Top K frequent elements LeetCode. Okay. Given an integer array nums and an integer k, return the k most frequent elements. You may return the answer in any order. Okay. your algorithm's time complexity must be better than n log n. So no sorting is basically what they're saying. There was... Man, what is... median of medians. Oh, man. You're trolling me right now. My brain is, like, actually being trolled. Okay, but, like, what if I sort the dictionary? Does that count? I mean, because, like, the dictionary is, like, it can be up to n, you know, but, like, not really. So, this is not guaranteed to be sorted. So yawny. Ugh. Alright, so what I will do is I'm just going to say, so first of all, I want to just jump into this one part. We're just going to create a dictionary that has the count. So I'm going to just say character count, right? And I'm going to make that a dictionary. And I'm going to say for element in nums, if element is in the character count dictionary, then we're good. We're just gonna say character count element plus equals 1. I'm just gonna add 1 to that. If it's not in there, we're gonna say character count element is equal to 1. Basically initializing it. So this is just a count. Gets our counting going. So now we have a list of all the counts, and this is O of n. And then now I'm going to convert this dictionary to a list. I'm going to say no, I'm not. Not going to do that because I need the key. Okay, basically what I need to do now is I need to find the largest... Oh no, it's n squared. That's so n squared coded. Okay, my first naive thought, which I believe is like potentially n squared, was basically to iterate through every single thing in the dictionary until you see the largest one. You'll do like the max approach, which is O of n, and once you get that, then you're good. And then you pop it, and then you keep going until you're out of K's. But like, that would low-key be very close to O of n. Sorry, O of n squared. My apologies. Because you're basically going through the dictionary K times. Although the dictionary gets smaller each time, and the dictionary already will be a little bit smaller than the length of the list, it's still just like, you know? Okay, this is as a follow-up. So, I'm going to just code that naive solution in, which is not the correct solution. At least I don't think it would be. Technically, it's faster than O of n log n, but it's not really, because it's like O of k factorial, you know? K factorial? Is that right? No. K choose 2? I think it's K choose 2. Which is like slightly less than n squared, but not by much. Not by much. Okay. And I believe based off of the rule, we just kind of bump it up to n squared. Alright, so I'm going to say solution equals blank array, and then I'm going to say while k is greater than 0. Then I'm going to do a little bit of a this, and that. I'm going to say max character. Okay, I'm going to put a max character here. I'm going to say for, I'm going to do equals none. I like null. For element, sorry, nope, not element. For key in character count, for key in character count, if max char is equal to none or character count of max char is less than character count of key, then max char is going to be equal to key. Okay, so that just iterates through, and then at the end of this list, I would like to say if max char does not equal none, how do I pop from a dictionary? Pop from a dictionary Python. Carta pop model. Peace. Alright, that's fairly simple. Man, Python is so English coded. Love it. Okay. And then solution.append max char and k minus equals 1. And then returns solution. Damn! But it was slow, you see? That's slow. Okay, so that worked. My naive approach worked, but I'm not liking it. I'm going to spend probably till 8:40 looking at it. Maybe not 8:40 because I'm tired. We'll see. I'm going to spend some time. If I feel like I'm getting nowhere mentally, then I'm going to take a step back and I'm going to look at the neat code. So I don't think... I need to be smarter because I believe this is not in login. So this is O of N for sure. I know this is O of N for sure. But this, right here, this... I could say confidently, I believe. Okay, so we're going through K. Not really bothersome. So we're going to say it's O of K times, and then we're going to go through the number of characters in the dictionary, which is... we'll just say that's J, right? And then I'm gonna say K. J is the number of hashes in the dictionary. It can be up to N, and so can K. K can also be up to N. So technically I could have a N squared approach with this. This could be N squared, which is way slower than N log N. Way slower. So objectively speaking, I can't say for certain that this is faster than nlogin. This is very, like, variable, right? I mean, random case, it's faster. Most likely random case, it's faster. But it just, you know, theoretically speaking, I don't know, like, where we would say this could be a political discussion on that, you know? We could kind of get into a heated debate about this. Which means it's not a solution that's good enough. Trying to think. My brain's so jammed right now. Whoa, voice crack. That's how you know I'm tired. Voice gave up on me halfway through. Okay. So what is another way I could do this? I need to stop looking at my naive approach because it's jamming my brain. I need to get that off my screen. Look at a blank picture so that way I can like get the brain juices flowing again. I'm giving myself just a couple more minutes before I give up. So, okay, I know there is a, there's median of medians, median of medians. I remember this, doing this in my algorithms class. It's been a minute since I've looked at it. Just asking in Python, because I can probably read it in Python. Oh my goodness, you're going to generate for me? Okay. Let's use a recursion. Oh my goodness, I haven't done recursion in a second. Oof. I hope I remember how to do my recursion, because once I get to it, I better know stat. It's going to be embarrassing if I fumble on the recursion. Okay, so that's what's useful to find this is median. Okay, but this is sorting. Oh, no. There you go. Fastest algorithms for finding the kth largest number in an array. A more efficient way to find the kth largest number in an array is to use a heap. Oh, yep. Crap. Am I gonna have to heap? Dude, I forgot about heaps. Heap time complexity. How do I do a heap? A heap just follows a simple rule that it's always bigger than its children. That's pretty much it. Have log of complexity for insertion of log n. And constant time complexity for peaking. O1. Okay, but if I'm literally going through in log k. Better than sorting. That's better than in log n. yeah, we're gonna run the heap magic. That's what we're gonna do. So I'm gonna say this is naive. Okay, and then I'm gonna say this is heap. Using max heap. How do you build a heap? Do I just... You can do it with an array. I remember it's like if... I'm sorry, I'm like so blanking right now. I remember it. Hold on. Let's draw this out. That's what we got this thing for. Top K. 347. Oh man, don't troll me. Copy. Okay. Okay, so for a heap, if I can remember correctly, it's like a heap looks like this, right? You'll have, we'll do a binary heap. I mean, I think you can do heap however you want, but I think binary heap is just like the simplest approach. Sorry, I had a burp. What you could do is you could make like an empty array of nulls. Right? So this holds each position. So I will insert it. So I'll say like, hey, I have, let's see, I want to find the largest out of 4, 3, 7, 2. Okay? So I'm going to insert 4 here. Okay? Then I'm going to insert 3. 3 is going to go here. It's going to look at it. And then it's going to go, is 3 bigger than 4? No. Okay. Then we're going to move it down. I guess we're going to go check it down. So, that's not how you do a freaking heap, dude. I can't. Do you do bottom up? Do I just pick a side? Man, I can't remember how to build a heap. It's been a year. Alright, hold up. We're gonna have to look up how to build a heap. How to make here you go, Google's literally listening to me. How to make a heap. Python. Teach me the ways, brother. No, I don't need a library. I need the pure video. Oh my lord. We don't need like a 30-minute
What's up,
video.
everybody? So in this tutorial, we'll talk about heap in Python. If you're new here, welcome. Be sure to check my personal website, nearlyblog.com. There are a lot of coding projects and articles which might be helpful to you. Alright, so the first question might be, what is heap? So personally, I have two definitions for it. One is heap is actually kind of data structure, just like main heap. So for the main heap, the parent node value should be smaller than all its children. So for example, if here's 1, then all its children, these 3 child children's value should be greater or equal than this. Otherwise, it does not satisfy the condition. Heap, to perform heap to this array, what you need to do is first call the library's name, then heapify this array. So let's have a look on what's going on to the function here. So previously, this is 5, 7, 9, 1, 3. Alright. So these can be built in sequence, just like this, in binary trace sequence. Alright. So it will start checking from the very first node, 5 here, which is the root node here, and all the way to the bottom, and do the iteration again and again until it finds the outcome for the current situation is identical to the previous array. Then it will just stop here. So let's have a brief demonstration on it, right? So first it will compare 5 and 7 and 9. Just 5.
No, I want to know how to make one, not how to use it. I want to know how to make it. I need to.
This is Wix Studio. Built to
You know what? Hold up. Maybe I could just use heapq. Why not? Can I just use heapq? No, because it has to be a key value pair, right? Yeah. Yeah, for sure. No, it has to be a key value pair. Alright, so I'm gonna yoink this one. This looks a little silly, but we'll see. Let's say list max list equals list of character count, and then I'm gonna print max list, and then I'm gonna use this silly heap thing. Heap q.heapify. Heap q.heapify max list, and then print that. Okay, do I need to install or import heap q? Maybe I need to spell it right. You know, that probably will help. What do I got? 1, 2, 3. See, okay, that doesn't really help me. Except, oh no, I need to find the reverse. Reverse. Okay, in linear time? What? Is that how fast it goes? We're gonna do this. We're gonna be silly goobers, very silly. We're gonna say max. Nope, that's not the silly. No! Oh my goodness. Pay attention. Max list dot append 0, and then we're gonna see it. Run it. Oh. Went too far back. Alright, so this works. Literally. Alright, bro, whatever. This is so silly. So silly. Alright. While k is greater than 0, I'm going to I need to study up on my heaps. This is a big lesson to study up on my heaps. Probably we'll do that tonight, or maybe tomorrow, or maybe more later down the line. But I have to do it regardless, because that is a very important data structure. Sure. Okay. While k is greater than 0, I'm going to make my solution. I don't need these. Actually, I'll keep these just for a nice little debug. Solution is going to equal that. Yerp. And then I'm going to say solution dot append max list of the 0th index. Indubitably. And I'm going to say max list is now going to be equal to max list 0 and onward. Right? Is that how you do it? And then k minus equals 1. Wrong answer. Oh, it's not returning nothing, man. Return solution. Still wrong. Cause I'm not popping it. Not popping it. Okay. I believe that should be faster, if that even runs. Oh, wrong solution. Oh, my days. Wrong solution because I'm being so stupid. No wonder why that's the wrong solution. How the hell did I even pass the first one? If you're watching this, I apologize. See, this is why I have to build a heap. I can't use Heapify right now because this is not gonna work. I need to build my own heap. Maybe I can use a heap. It's just like, how do I build a heap? Teach me.
When your project calls for bold creativity, design freely on
Like, not in like 40 minutes.
And thus also how to use a priority queue in Python, and the heap from where heap is. Already said, basically a heap is an implementation of a
Yes, no, I know.
go through a list, and we have linear runtime complexity and so on. So we don't want to have that. We want to have an efficient way of inserting data. And in a heap, we just have to insert it at the end, and then we have to do this heapify operation. And the maximum amount of steps we need is logarithmic. So the runtime complexity in a heap for entering a new element, inserting a new element, is actually logarithmic, which is better than linear. If you want to know more about runtime complexity, take a look at my algorithms and data structures course. It's for free on YouTube. I think 4 hours. There are a couple more theory. And essentially, we have now this data. And in order to turn this data into a heap, what we do is we say heap, or let's say heap data equals heap queue, or actually we don't need to return it. I think we just say heap queue, heapify.
Oh.
So on and so forth. We basically just follow these.
I'm asking how to make one, not use one. Oh my days! I just want to make a heap, brother. No, no, no! Stop! No more! Oh my god! I just. Please, no more heap queue. Thank you, but no, please. I need to create my own heap. No! Oh my god! Oh wait, wait. No, you're trolling. You're trolling. Fucking trolling, bro. Okay. How does Heapify work? I need to just visualize it real quick. Heapify is a process that no, I know like what the output is. I need to see what it does. Okay.
Rumley is basically like an AI writing partner that can help you solve all of this. For example, here's a bunch.
Oh my god, wait, I forgot this guy's good. Wait, hold on, let me listen to this person.
And so as we go, the performance of this is going to be in log n time. So this will get us there, but as we've said, it's going to be in log n. It turns out that there is a better way. The basic concept here is that we're going to simply say, okay, I have an array of data. This is all part of a heap. A currently quite broken heap, but it's a heap.
Yeah.
Then, of course, we need to fix the heap. And the whole point of the Heapify algorithm is to fix the broken
For each parent, from the last down to the first, do a percolate down.
heap. In big O of n time. I'm not going to demonstrate the big O of n part, but I'm going to show you how this algorithm works. So we have the 2 there, and then that we were working with before, the same initial array. So we start then with the last parent, which is at index 3. 7 divided by 2, integer division. Three. So we have the 2 there, and then its children are at indexes 6 and 7. So we compare those 2 children. 12 is the larger. It is also larger than the 2, so we need to do that swap. At that point, our percolate down is finished because the 2 has no more children. The next parent that we need to look at, the next index, is the 2. This is just a for loop counting down from that initial value for the index to 1. So 3 minus 1, 2. Here we are. So we compare the children of the 9, which are indices 4 and 5. 15 is the larger of those 2, so we're going to end up swapping the 15 and the 9. The 9 now doesn't have any children, so we're done there. Then we get down to our final percolate count at the root with the value 7. So its children are the 15 and 12. We compare those. 15 is the larger. It's larger than the 7. So we do that swap. Now this time, the 7 still has children to check. Its new children are the 9 and the 10. The 10 is the larger of those 2. So we'll swap the 10 and the 7. Now the 7 doesn't have any children, and we're done with a correct max heap. And that's all there is to this algorithm. We're just going to run a for loop from the last parent, the one in divided by 2, up to the root, or down if we're counting by indices to the root. Do the percolate down from each of those, and at the end, we're going to have ourselves the kind of heap we're looking for. Thanks for watching.
Today we're going to learn about heaps. You often hear the word heap when discussing storage for garbage collection in languages such as Java. But this video is about the heap data structure that is used to manage information. Parent. The value of its parent. We choose to put the root at index 1 instead of 0, as it keeps this arithmetic cleaner, and most computers can do these operations with fewer instructions. Let's take a look at 15, which is at index 3. The left child of 15 is equal to 2 times 3, which is the 6th index, and a node value of 12. The right child of 15 is 2 times 3 plus 1, which is the index of 7, or the node 13. Lastly, the parent of 15 is the floor of 3 divided by 2, which is the first index and the root of our tree, 21. You know I prefer brevity, so we'll end the video here.
Alright, I'm gonna have to make a heapify, so I'll call this Sterling doesn't know how to spell bougie. Call this bougie heapify. Cause we got on us like that. Type. Nope, we are not doing C#. We are doing Python, brother. Don't forget your colon. Thank you. Alright. We're doing heapify. Kill. We're gonna take a list. We're gonna call this max list. And this is a list of list. Wow. Fantastic. Who would have ever guessed? Oh, wait. Because it can't even get better than that. And it's going to be a list of integers. Oh my goodness, it's beautiful. It's beautiful. So, we're going to do some, him and a minute. Okay, they say start from the bottom, go to the top, and go back to the bottom, right? Yeah. Let's build this. Oof. 9 o'clock already. So sad. So sad. Okay, apologies. That itchy nose. Alright, so come on, brain. It was like we're gonna start on the last one. We're going to start on the last parent, which is probably gonna be on the right side, You jive with me? Okay, hold up. I need to start thinking real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So it's like... Damn, what is the... Hada. She honestly was cooking with her explanation.
The children of the night. It is also we have the that we will have a correct.
For each parent from the last at n divided by 2 to the first. Is that always the case? Is it always the...
So let's do that with the same heap that we were working with before, the same initial array. So we start then with the last parent, which is at index 3.
Is that really always the case? Huh. Sterling, you need to learn more. Brother, what are we doing? We need to start cooking. Okay, so. My apologies, twin. The last parent is going to equal length of max list integer division. That's integer division, right? It better be. It better be. It better be integer division. Integer division. Integer division. Python. Yeah. Type. The results round down to the nearest negative. Beautiful. Beautiful. That's what I want to see. Okay. And then I'm basically going to say, if, like last parent, man, y'all are watching me learn how to do basic freshman data structures in real time. It's getting cooked out here, man. It's getting cooked out here. It's not looking good for me. If last parent, and I need to stop doing these parentheses, man. Holy crap, what am I doing? It's less than the max of cleaner if it's one indexed. So let's say last parent plus 1 actually no, that's not what I'm doing. I'm just say times 2 plus 1, and then I'm gonna say crap. Ah, man. This is so annoying. This is so incorrect. Because I'm gonna have to check. Oh my days. Oh my goodness, I'm getting annoyed. Ah. What are you doing? Okay. Alright. This just checks the max value, but this is annoying because it's just checking the value. Right? Okay, so this is where I'm gonna have to write some inner if statements. I'm gonna basically just say, hey, if then I'll have to swap with that, then I'll basically say that man, this is chopped as hell. Holy crap, this is so chopped. Aggravatingly so. Make a little bit of a swap. I think Python has a swap library, but you know what? We are balling right now. And I'm gonna say max list of last parent is equal to the greater of the two. Should be this one. And then and this is going to equal temp. Okay. Beautiful. Then I'm going to say just else. Okay. So that's the function. I'm getting lazy. I literally just want to see the heapify function. Please just give me the heapify. I'm literally on my knees crying right now. No. What? Oh my goodness, it's getting super late. Alright. I might have to just call this wrap for a second. Like, I know how to I know the solution is gonna require a specialized heap. I just have to remember how to make it, and these solutions aren't not looking correct. This is just basically checking if you update it, then go down. But this only qualifies after the final update. Okay, here we go. You know what? We're cooking now, I guess. Sad days. And then I'm just gonna say, I'm really doing too much right now. Like literally, what the hell am I doing? No. Doesn't it automatically go down? Alright, we're gonna listen. Dude, this does not look right at all. Oh my days. This is horrible. It's so bad. um. I don't think this is gonna work. I think this is gonna crash. Alright, for key in character count. And then I'm going to say that max list dot append character count key. And I'm gonna print max list. Okay. Run this and expecting an error, a runtime error. Because I misspelled that. Okay. Cool. Yep. Yep. That's what I like to see. Alright, and now I'm going to say that max list is going to equal build heap of max list. And I'm going to print max list. And I'm probably going to go an infinite runtime error. Okay, yep. Unbound local error. Cannot access local variable build heap where it is not associated with a value. Do I need to put it at the top? I thought that was like just a C# thing. I thought I could put it wherever I want. Yeah, I can. Oh, it's because I forgot to name it the proper name. Bougie Heapify. Bougie. Doesn't matter because it's already sorted. So I'm gonna add in a 04 just to throw a wrench in there. This is not gonna work at all. Sorry. Can't handle even numbers. Yeah, I don't know. Yeah, I don't know about that. Man, 9:23. 40 minutes past when I said I was gonna call it. I'm the worst liar ever. This video's gonna go on forever. Waha. This is the process of just hitting your head against the wall over and over and over. Which is not what I am not supposed to do that. I am not supposed to do this at all. I'm supposed to give up early, but I can taste it. I'm like so close. And yet, the closer I get, the sloppier the solution gets. I'm trying to make a priority queue, per se. Pretty much all I'm trying to do. I just don't remember how to do it, because I'm silly. I'm not handling nuns at all. I gotta be very careful about, you know. There's a min, right? It's a function. This is not running right. Ah! I need to give up. This is not gonna work. This is so disgusting. I can't do this no more. I'm gonna cry. Ah, no! Don't worry about the method, okay? This is horrible, but this is what happens when you have no idea what you're doing. It worked! It worked! That's terrible. Yeah, it's terrible. Okay. Yep. That's that. We're going to... Well, k is greater than 0. I'm going to say max list equals build heap for max list. And I'm going to say a solution is equal to this. I'm going to do solution dot append max list. Whoops. Max list. And that max list is going to be equal to 1 onwards, and then k minus equals 1, and then return solution. Oh, that's slow. Ooh, that is slow. Did I like burn the food? Alright. I thought I ate. But that was still slow as fuck. Apologies for the language. Slow as heck. What the hell? It's so slow. Okay, so you just watched a madman spend 40 minutes doing nothing. We're gonna check it, and we're gonna watch the video. Gotta pay attention, okay? We listen. Oh, oven time? Yo, I burnt the food. I'm cooked. A nice solution would be to count the frequency of each number and then sort the array based on each element's frequency. After that, we would select the top k frequent elements. That would be O of n log n. Is there, though the solution accessible, do you think of a better way? Can you think of an algorithm which involves grouping numbers based on their frequency? Bucket sort? Hell no! Oh my god, hell no. We genuinely doing bucket sort in 2025? You're joking. Oh my god, I almost just threw up thinking about that. That PMO GNG, holy fuck. Okay, this is what I did, but worse. So what is my original solution? My naive solution was like, I didn't sort, did I? Did I sort? Oh, this is just horrible. Amen. Sometimes you burn the food, sometimes you don't. That time I burnt it. I burnt it bad. Ooh. Sorry, I'm reading this. Yeah, I hear you, big dog. Did you heap sort this? Yeah, I'm still not cooking. Alright, man. Let's look at the bucket sort. Try not to gouge my eyes out. Ah. It's an array of rays. Okay, I feel you, man. I hear you, man. It's interesting. This get thing is like, hey, if it's null, then just give you 0. That's pretty smart. Alright. I hear you. Chill. Okay. Hey, big guy. Okay, so I have all the frequencies lined up. Alright, I'm about to study up on my bucket sort another day. I'm reading it, but it's not hitting me. It is so late. This video has gone on for way too long, and I am tired. I'm tired. Over time! My cat's mad at me right now. He wants to hang out. Okay, we're gonna take that as a semi-flop. I mean, we got 2 solutions. We absolutely battered this one into the wall. We kind of, technically this is valid, I think, but a good solution would have been bucket sort, which I didn't even think about because I haven't thought about bucket sort in 3 years. I don't want to think about bucket sort. I hate bucket sort. But yeah. Sorry that video went on for so long. Thank you for watching, and I'll see you tomorrow.